I will teach you for this course, Dr. Azhar. Okay. Your lecture will be each Tuesday from 10 to 12 p.m. Of course, our lectures will be always online and will be quizzes, online activities with the quizzes and TMA. And of course, the final will be written at the campus. Of course, we will have more details later about the grades and the marks, how will be arranged between these things between final and at TMA. Okay. For this course, okay, this can you see the slides?
Yes.
Okay. For this course, of course, as we said, we will have calculus and probability. This course will be about the outline, the main outline of this course will be about, first, we'll study function. Just a minute. We will study functions. This will be the first lecture. Then we will study its derivatives. I think most of you at high school or secondary school, you studied the derivatives and the integrals of the functions. And we'll take some applications of these derivatives and, of course, some techniques of differentiation. Then we will present the logarithmic functions and its applications and how to make its derivative and its properties. Then we will begin with the finite integral. After finishing the derivatives, we will study the integrals, then the trigonometric functions. Trigonometric function, I think that that you know the functions sine and cosine and so on. We call these functions trigonometric functions. Then we will finish with probabilities and calculus, some applications. Okay. First, let's just record this lecture. I'll take the attendance later in this lecture. As we said, we'll begin the first lesson with functions. In functions,
Something?
do you have a question?
Yeah. If I want to attend with another doctor, because I have my timing is not it doesn't match for my date. So how is the attendance with you will go?
I'm not sure about that, but you have to attend at this class for the records. You can attend at any class, but I have to take your attendance here. If you want to change your section, you can send an email to the coordinator, BCC.
Okay, thank you.
Welcome. Okay, functions and their graphs. We will take some functions and present their graphs, how to make graphs of function or sketch the function. Some important functions. There's many kinds of functions. And the algebra of functions. What do I mean by algebra? Algebra, the operation that I make between functions, which is the summing or adding subtracting and multiplying and dividing. This is the operation or algebra between functions, and also another function or another operation that we will present later. Okay. Okay. And of course, we will present the zeros of a function. There's so many applications of finding the zeros. The zeros of the function is like solving equality with the zero. Then the quadratic formula and factoring. This is actually two methods to find the zeros of a function. Then the exponents and power geometric problems. We will finish with the geometric problem. This will be the main outline of this tutorial 1 for the function. Okay. Before we begin, we should present the real numbers. What do I mean by real numbers? Real numbers actually are two groups. It's divided into two groups, which is rational number and irrational numbers. Rational number or numbers are numbers that I can write it like that as numerator and denominator, like that, and infinite, of course, infinite as a finite number in the top and finite number in the bottom. And when we divide it, as you see here, like that, 2, 8, 5, 7, 1, 4, then it will be repeat 2, 8, like that. As you see, it will be repeated when we take the division. So we call it a rational number that we can write it like that. And when we divide it, it's repeating, infinite repeating decimal. Of course, any integers are rational number. Of course, for example, 2, I can write it like 2 over 1. This is a rational number. Okay. Irrational numbers, like the roots, square roots, the square roots are actually irrational numbers. When we find the value of the square roots, it's infinite decimal and it doesn't repeat like this. Here we will have distinct numbers to infinite, to infinity, of course. Okay. Okay. The groups of rational numbers and irrational number together present the real numbers. So real numbers actually are rational numbers and irrational numbers. Together are real numbers. So real numbers are all the numbers which are the positive and negative and the rational and irrational numbers. Okay? Do you have a question? Muhammad Akram.
Teacher, good morning. Can you please speak Arabic? We can't understand.
Actually, it's I can't speak Arabic or explain in Arabic, but if you don't understand something, I can repeat it briefly in Arabic later. Okay. I think you should. Yes.
I have a question. Now this slides, you'll send it to us?
You will find it on LMS. The LMS just opened yesterday, I think, but you will find it later on LMS. It will be there.
And all the slides and our books will be there?
Yes. All your materials you need, will be found in the LMS. Okay. Thank you. Okay. Okay, if you didn't understand what I said before, I will repeat now. In briefly or راح أعيد اللي قلته بسرعة بالعربي، بس طبعا مو طول الوقت راح يكون في شرح بالعربي. اوكي، راح يكون هذا التوتوريال الأول عن الدوال اللي هي الفانكشنز. أول ما راح نبدأ راح نعرف الأعداد الحقيقية اللي هي الريال نمبر، اللي تتكون من الأعداد الكسرية أو النسبية والأعداد الغير نسبية irrational numbers. الأعداد النسبية أو الكسرية اللي أقدر أكتبها كبسط ومقام بصورة منتهية بهذا الشكل، مثل هذا الرقم اللي هو 2/7. لما أقسم ب2/7 راح تتكرر الديسيمالز هنا، الديسيمالز اللي هي الأعداد العشرية اللي يمين الفاصلة. لاحظوا هنا تكررت الأعداد من 2 ل4 مختلفة، بعدين رجعت تتكرر من 2 ل4 وراح ترجع تتكرر إلى ما لا نهاية. أقدر أكتبها بهذه الطريقة فوقها خط. ومثل هذا يكون طبعا النص أقدر أقسمها بشكل منتهي just 0.5. وجميع الأعداد الصحيحة الموجبة والسالبة أيضا هي أعداد نسبية اللي هي rational. أقدر أكتبها أن المقام يكون 1 وتكون rational number. طبعا حالات خاصة من irrational numbers. irrational numbers اللي هي الأعداد الغير نسبية اللي ما أقدر أكتبها كبسط أو على مقام، أو إني لما تكون أكتبها بالديسمال نمبرز أو الأعداد العشرية تكون أعداد غير منتهية وغير متكررة. لاحظوا هنا no repeating pattern، هنا ما راح تتكرر الأعداد على يمين الفاصلة، راح تكون أعداد مختلفة. أوكي. أوكي. Infinite and open and closed intervals. Okay. The intervals, what do I mean by the intervals? The intervals is the line number like that, of course, with a 0 in the middle. And in here will be the positive, and in the left will be the negative. Here the positive numbers and the right of the 0, and the negative numbers at the left of the 0. And the 0 is the origin. Of course, here I can divide it into the integers here, 1, 2, 3, 4, and of course between them will be some rational and irrational numbers. And from here the negative, -1, -2, and -3. Okay? Do you have a question? You raised your hand, Muhammad Akram.
No, I don't have anything. Thank you.
Okay. Okay. Okay, this is the line numbers. Of course, this is the origin, and how to present the intervals on this line. For example, if we have 2 here and -2 here, all the number between these two numbers, all the numbers here, so either irrational or rational or integers or even the 0, if I arrange them or restrict them with between -2 and 2, will be an interval here from -2 until 2. Of course, here I make an open circle on 2 and -2. So I write it like that, around brackets or circle brackets like that. So here 2, it's not in the interval. It's not in the interval -2 and 2. And also -2, it's not in the interval. Okay, I call this an open interval. This interval is open. Open means that the endpoints, here the endpoints -2 and 2, are not included in between the intervals. Just the numbers between these two numbers. Of course, -2.1, which is here, for example, it's inside the interval, -2 and 2. And of course, the 0, it's in the middle here, included in the interval -2 and 2. But only the endpoint, since the circles here are open, only the endpoints are not in the open interval. Okay? Okay.
Which mean number 2 it's not included?
Yes. The -2 and 2 are not included in the interval, since the circles that I draw are open. So they are not included. But if I close these circles like that, closed circle like that, so the endpoint are included. And I write it like that, -2 and 2 with the square brackets. This is a closed interval, okay? This interval is closed. When I write it like that with these circles, means that -2 and 2 are included, sorry, here included, or like that, included in the interval -2 and 2. This is a closed interval. And I present it like that, from -2 to 2. This is a closed interval, okay? Okay, we still have to define the infinite interval, okay? As we said, open interval and closed interval are the same, but it differs with the endpoints. The closed interval have the endpoints and the open interval doesn't have the endpoints, okay? For example here, if I have the line number like that, and if I have an endpoint, let's say, for example, it's 3. If I take all the number, for example here, all the number at the right of this number 3 until the infinity. Of course, here the plus infinity and here minus infinity. All the negative number until infinity. If I take all the number here at the right of the number 3, it will be an infinite interval. And I write it like that. Of course, this will be open since the circle here is not closed or not, of course, it's open, not colored. Open from 3 until infinity, like that. This is an open interval, but it's infinite. Open and open from the left and infinite. Infinite interval. Infinite interval. And if it's closed like that, it will be closed interval like that. Okay? And of course, from the left, like that. If I take any number, for example, here, let's take 1. Of course, it could be a negative number, minus infinity to infinity. If I take all the number at the left, like that, it will be also an infinite interval, and it will be from, always begin from the left, from minus infinity. I always begin from the smaller number, which is here minus infinity to 1. And it's open since the circle here is open. Or of course, if it's closed like that, it will be from minus infinity. It will be the same from minus infinity until 1. And it will be closed like that. Okay? This is also an infinite integral, but it's from minus infinity. This is until infinity. We always begin from the left to right when we write the interval. Okay? Okay, let's repeat what we said in Arabic. عندي الفترة المفتوحة مثلا من سالب 1 إلى 3. هذه أسميها فترة مفتوحة. هنا أمثلها على خط الأعداد تكون من سالب 1 إلى 3 بهذا الشكل على خط الأعداد. تكون جميع الأعداد بين العددين بهذا الشكل. ولو كانت فترة مغلقة closed interval فترة مغلقة سالب 1 إلى 3 تكون نقاط النهاية للفترة محتوى داخل الفترة اللي هي هنا طبعا أطمس النقاط عشان أدل أنها محتوى داخل الفترة from minus 1 to 3 جميع الأعداد بين هذين العددين تكون فترة مغلقة إذا كانت الإند بوينت أو نقاط نهاية الفترة نهايات الفترة محتوى. هذه أسميها open مفتوحة وهذه أسميها closed. أوكي؟ هذه أسميها فترة غير منتهية infinite غير منتهية whether it's open or closed. سواء كانت هذه مفتوحة أو مغلقة راح تكون في كل الأحوال infinite. Of course, the longest interval in the line number, the line of numbers will be from minus infinity to infinity. This will be like that, minus infinity to infinity. And the brackets always, beside the infinity, always open like that. It's always circle the brackets. اوكي دائما الفتره شكل القوس اللي عند الما لا نهايه والسالب ما لا نهايه دائما اعملها بهذا الشكل. مستحيل انه يكون قوس مربع or squared like that. اوكي okay, this is all about the intervals. Okay, of course you have here in the slide the definition of infinite intervals and closed interval and open interval as well. The set of all numbers that between a given end point and the infinity. This is the infinite interval. Okay, like that, from 4 to infinity, and I present it like that. Open from 4 to infinity, which means all the numbers x that are greater than 4. Like note here that all the number here are greater than 4. So I present here all the number that are greater than 4. For the closed interval, I mean all the numbers between -1, for example here -1 and 4. And since the circles here are closed, so the end point are included in the interval. And I write it like that, squared brackets. And I mean by that all the numbers x like that between 4 and -1. Not here that I write here greater than without equality. Okay, 4 is not included in the interval. But here, since the interval here is closed, so I write the equality here with the less than. X is greater than or equal -1 and less than or equal to 4. I write the equality since the interval here is closed. For example, here, when I have here closed from 4 to infinity, I write it like that, from -4 to infinity. So it will be all the number x greater than or equal, equal to 4. Okay, if it's here is closed, so -4 is included, I write the equality here. But if it's open from here, I don't write the equality, it's just greater than. The same here for the open interval. I mean by that all the numbers x between -1 and 4, but not the endpoints. It's not equal to the endpoints -1 and 4, only the numbers between them, like that, without equality. Okay?
Okay.
Okay, functions. Now let's define the functions. رح نبدأ بتعريف الدوال. I define the function by the letter F. Of course, the first letter here of the word functions is the letter F, so I named the function with the letter F. Most of the time, we'll have F as the name of the function. Of course, we can write another names for the function other than F, but it's the main letter that we will use. Of course, the function is a rule that I use on a variable or numbers, which I call it here, for example, x. When I applied the function, the rule of the function on x, I will have the variable y. I will have the value of y if I applied the function f on any number x. We will understand this later when we have some example. But now for the notation, f is the function, like that, and x is the variable معناها متغير, and y also is a variable, but I can have it depending on the value of x. Okay, I can have it or find it from the value of x when I apply the function f on it. Okay, I call the variable x the independent variable. X is the independent variable, and I call y the dependent. Okay, dependent variable, which means that I can choose any value for the independent variable x, but the variable y I can only find it by the variable x. هنا المتغير المستقل اللي هو x، أقدر أنا أحط القيمة المناسبة من عندي اللي هي للx أو تكون معطاة عندي، لكن الواي هي قيمة أقدر أوجدها فقط باستخدام الx، ما أقدر أحط قيمة من عندي للواي، فهي تكون متغير تابع للx.
Hello, Miss.
Yes.
Can you explain in Arabic, please? Because not a lot of students know how to know English. They can't understand.
Okay, I'm here explaining in English and Arabic as well.
Yeah, because they don't understand. Thank you.
You're supposed to finish the courses on English, like the first courses, right? Most of you at least understand the basics.
Yes, I understand. We finish our lessons in English. 98, 99.
Okay, I will try. I shouldn't supposed to explain in Arabic at all, but I will try to explain after English something in Arabic. Okay, let's continue here. مثل ما قلت لكم هذا المتغير. Yes.
Just to be notified that in the courses they don't teach us functions and all this like words and math and stuff. They don't teach us at all, so that's why we don't understand. That's it.
Why you don't understand the English?
Well, yeah, I do understand English, but I don't understand function word, you know, the stuff that you were saying.
You mean
In English, yeah, this word in English, I didn't understand it, so.
you understand the English, but not the new words for you.
المصطلحات في الرياضيات ما أفهم.
أيوة فاهم. الفوكابيولري, the new vocabulary that you don't understand in math.
صحيح.
Okay.
أصلا في الكورس أبدا ما علمونا وقت حكي عنها أصلا.
طيب راح أحاول إني أول ما أشرح أقول لكم المصطلحات كلها بالعربي. لكن الشرح أنا ملزمة أن الشرح يكون بالإنجليش. راح أشرح أول شيء بالإنجليش وحاولوا تفهموا معي وراح أعيده بشكل مختصر بالعربي. فحاولوا أنكم تتابعوا معي وتركزوا. راح أقول المصطلحات في البداية بالعربي عشان تقدروا تفهموا معي اللي أقوله. وبعدين راح أعيد الشرح بشكل مختصر بالعربي. طيب هنا مثل ما قلنا إنه المتغير المستقل اللي ممكن أنا أعطيك القيمة أو تقدر أنت تختار القيمة من عندك. تعوض في الدالة F بالمتغير X للحصول على قيمة المتغير Y. عشان كذا المتغير Y أو الفاريبل Y أسميه dependent variable أو متغير تابع. أقدر أوجده فقط باستخدام الدالة F أو باستخدام المتغير X باستخدام الدالة F. Okay. This is the main definition of the functions F. Okay. Here in the slide you have the definition. A function F is a rule. I give you the rule. أعطيك القاعدة اللي فيها تعريف الدالة F. Assigns to each value of a real variable X exactly one value. طبعا هنا من الشروط أنها تكون دالة. من الشرط أنها تكون دالة أن لازم تعطيني قيمة واحدة فقط. لما أعوض بقيمة X ضروري أن تنتج لي قيمة واحدة فقط للمتغير Y. أوكي. إذا أكثر من قيمة هذه طبعا تتنافى مع تعريف الدالة. Only one variable for another variable Y. Meaning that if I take X and substitute it inside F, إذا عوضت بالمتغير X في الدالة F ضروري إني أحصل على قيمة واحدة فقط. Only one result or one value of Y. For example, معنى الكلام اللي أقول أنه one value. For example, here when I take square root, for example for X, it assigns either positive or negative of X, right? Here for example X square, positive or negative of X. You know that, right? For example here the square root of 4 is either positive or negative, minus or plus 2. So here I can say that all the values like that f of X is square root of X square is a function. Only either the positive or negative when I draw it, okay? That's mean what we call that's what we mean by one value for Y. Not all the values from the square root represent a function, only the negative or the positive side. Okay. Now here for some examples for the function. Here, as we said here, X we call it independent variable and Y is dependent variable. طبعا أنا راح أشرح لكم بالإنجليزي لأن الاختبارات والكويزز كلها راح تكون بالإنجليش، فلازم تتعودوا على المصطلحات اللي تنقال كلها بالإنجليش. أكثر اللي يجوا يتشكوا من درجاتهم بالفاينلز بالامتحانات وهذه الأشياء أساس أنهم ما فهموا السؤال لأنه كان بالإنجليش، فضروري أن الشرح والمذاكرة تكون كلها بالإنجليش نفس اللي راح تختبروا فيه. We usually write y equals to f of x to express the fact that y is a function of x. Right? F of x is a function of x, represent the values of the dependent variable y. And f is the name of the function. As we said, we can present another name here, f of x, another name of f, the function here, f. We can say g, s, k, or any other letter to present a function. Also, the dependent variable, like x, I can actually present it like another letter. Maybe z, maybe here t, maybe a Greek letters like theta here, or any other letters for the dependent or independent variable. Okay, here I can say f of x or g of x as a function. I can say f of z as independent variable for the function f, or maybe g of t, the function g with the independent variable t. Okay. Here are some examples of functions. Here, f of x is defined by x squared plus 4. Means that I take all the values that I'm given in here. For example, let's erase here. When I said for x equals 1, f of x that I defined here, I substitute mean عوض. When I substitute in the function here by the value of x I'm given here, it will be 1 squared plus 4, which is 1 plus 4 equal to 5, like that. This is how the function works. I substitute with the independent variable in here to find the dependent variable like that. Here, since x equals to 1, after substitution, the function will be equal to 5. I present it as a point. This is not an interval, as a point like that. X here and y at the right. X I presented or substitute by 1, and the result is 5. This is a point, not an interval. It looks like an interval, but it's a point. And I can present it in the plane like that. X equal to 1 and y equal to 5. Here 1, 2, 3, 4, 5, like that. So this point is 1 from the x-axis and 5 from the y-axis. This is a comma. This is the point presented by substituting x by 1 and resulting 5 for the y. The point 1 and 5. Okay?
Okay.
Okay. Now for example here, the function g of z. Here, this is z. The independent variable here is z. So when I give you, for example, a value like z equal to, let's say, -2. So I have to find y, the dependent. This is the independent variable, so I have to find the dependent variable y, which is g of -2, like that. Okay, which is 1 over, this is 1 over. Instead of this z, I will replace it by -2. like that. Then from the definition here, minus 3. It will be 1 over minus 5, like that. So this will be a point, minus 2 and minus 1 over 5. This is the point. I can also present it in the plane. Here the independent variables will be z, and the dependent will be y. So it will be here minus 2 and minus 1 over 5. It will be somewhere here, a point. Okay, this is the point. Okay. And also for example, this is a square root function, square root t square minus 1. Of course, it's a function, but I can divide it into two parts, which is positive part and the negative part. It's not our subject now. K of theta, this is also a function named by k, and the independent variable here is theta. Theta. Okay. Here I substitute or replace the independent variable theta here by any value. Of course, here also on the second term is sine theta. From here and here, when I, for example, said that theta equal to pi, for example, you know pi, which is exactly 3.14 and not exactly, it's around 3.14, but it's actually an angle. هي تعتبر زاوية، الباي تعتبر زاوية لما أعوضها بالساين. أوكي، بس طبعا هذا مش موضوعنا. المتغير التابع هنا راح ينتج عن طريق التعويض بالمتغير المستقل اللي هو الثيتا. أي قيمة أعطيك إياها للثيتا أعطيك إياها للثيتا ممكن إنك تعوض فيها. For example هي إذا عوضنا بالباي راح يكون التعويض بهذا الشكل. طبعا مش ضروري هنا نوجد القيمة النهائية. راح تكون k of pi equals to e. E here is the is a number, is a real number. You will find it later in the exponential function, not now. It's an exponential function. Here the base is a number. It's actually a number. It's around 2 point something. Okay. ال E هنا هي عبارة عن عدد حقيقي تقريبا قيمة 2 فاصلة. هي عبارة عن دالة أسية exponential function مرفوعة إلى أس. الأس يحتوي على متغيرات. هنا العدد هذا عدد ثابت حقيقي ثابت لكن مرفوع إلى عدد متغير اللي هو هنا الثيتا. راح تكون E to the power minus 2 divided by pi والثيتا قيمتها أعطيتك إياها باي plus sine pi, like that. Of course this is an easy هذا طبعا تقدر توجدها بسهولة حتى من غير آلة حاسبة. هنا ممكن الباي تختصر مع الباي فتكون e to the power minus 2 plus sine الباي اللي هي ساين 90. بس هذا مجرد أمثلة مش ضروري نوجد القيمة. أوكي، هنا الغرض بس أمثلة لبعض الدوال. ممكن تكون دالة بهذا الشكل، مجرد دالة أسميها كثيرة حدود أو دالة تربيعية x تربيع زائد 4. ممكن تكون دالة كسرية بسط على مقام، ممكن يكون المتغير في المقام أو في البسط، وغالبا طبعا هنا عشان أسميها كسرية يكون في المقام. ممكن تكون دالة جذرية، المتغير يكون داخل الجذر، وممكن أيضا تكون دالة أسية زي هنا x to the power، وممكن تكون دالة مثلثية اللي هي الساين أسميها دالة مثلثية أو trigonometric function. أوكي، هذه بعض أنواع الدوال some types of functions. Now, some applications on functions, بعض التطبيقات على الدوال هنا. For example, if you have this definition of a function f، هذا تعريف معطى للدالة f، x squared plus 4x plus 3. This is the given definition. Here, the claim is find f of minus 2 and f of a minus 2. So here I have to find two things. First, I have to find f of minus 2. When I finished, I have to find f of a minus 2. Okay? So first, here, first I will find f of minus 2. Okay? How to find f of minus 2? كيف راح أوجد f of minus 2? I just substitute the independent variable x by the given value which is minus 2. راح أعوض بقيمة المتغير x اللي هو المتغير المستقل x بالقيمة المعطاة داخل القوس اللي هي minus 2. Okay?
Okay, clear.
Okay.
Okay. Here, let's begin. X squared, which is minus 2 squared instead of x, plus 4 multiplied by x, which is here minus 2, plus 3. So here, note that only here, only the variable x. Here, I substituted by minus 2. And only here, x, I substituted by minus 2. And all the other algebraic things are the same. Here, x squared minus 2 squared plus 4 multiplied by minus 2 plus 3. Then compute. Minus 2 squared, of course, minus square, it's plus. Minus 2 squared is 4. أيوة 4. Here minus multiplied by
8.
plus. Yes, minus 8 plus
3.
Plus 3.
It's
Minus
be
one.
minus 1.
Okay. Okay. 4 minus 8 is minus 4. This is minus 4 plus 3, which is minus
1.
minus 1. Yes, minus 1.
Minus 1.
Right, minus 1. So here, f of 2, I find that it's equal to minus 1. So I can present it as a point like that. Here, on the beginning or in the left, I write the value of x, which is minus 2, and the value of y, which I found, which is minus 1. Okay? This is the point or the solution. Okay? Okay, this is the solution of f minus 2. Now, let's find f of a minus 2. Of course, a could be any real number. It's not a variable. It's a general real number. It could be any real number, like that. By the same way, here instead of x squared, I write a minus 2 instead of x. I write a minus 2 like that, and keep the brackets like that. Here plus 4 multiplied by x. Instead of x, I write a, yes, a minus 2 plus 3. Yes. Here, I use the quadratic expansion, which is a squared minus 2 multiplied by the first and the second. Here minus, so here minus. 2, this is not the same 2. This 2 from the formula, the expansion. 2 multiplied by a and 2. as well. So here, multiplied by A multiplied by 2, plus 2 square, which is 4. Yes. So this is okay. So this is the expansion of this square formula, sorry. So this is the A minus 2 square. All of this is the first term. Okay. So here, plus 4A, here I just distribute.
I can't understand the last step.
Which one
Can
here?
you repeat it? Yes. We use يعني خاصية التوزيع.
أيوة اللي هي إذا كنتوا فاكرين اللي أخذتوها اللي هي A plus B الكل تربيع.
الفرق بين المربعين.
مش الفرق هنا. مربع المجموع اللي هي A تربيع زائد 2 AB زائد الB تربيع. هذه اللي استخدمناها.
Yes,
okay.
Yes.
Okay, the second term I only distribute 4 inside the brackets like that. 4 multiplied by A minus 4 multiplied by 2. Okay, this is the second term. This is the second term. That. Finally, plus 3. Don't forget this constant term, plus 3. Okay, equals 2. Now I just simplify to find the final result. Okay, here A square, nothing will be changed. Here 2 multiplied by A multiplied by 2 plus 4A plus 4. This is the for the same. Here plus 4A
or minus 4A.
Sorry, this should be minus. This one minus. And this plus 4A minus
8.
Yes, minus 8 plus
3.
Plus 3 equals 2. Now, to more simplification, we denote here, of course, this is A square minus 4. Here, note here that minus 4A and plus 4A, I can omit it together. Okay, it's the same quantity with the different signs. نفس الحد لكن بإشارات مختلفة. أقدر إني أحذفهم مع بعض. Okay. So what all the remaining is
minus 1.
Yes, the numbers here. 4 minus 8 will be minus 1. Sorry, minus 4. Minus 4 plus 3, which is minus 1. So the final result here is A square minus 1. So here, f of A minus 2 will be A square minus 1. The point here, x, which is A minus 2, and the value of y is A square minus 1. This is the value of x, and this is the value of y. Okay?
Okay.
You understand? Should I repeat with in Arabic?
Yes, I understand.
It's clear.
Okay.
Teacher, just wait. I'm just write all this example.
Okay. It's all actually written in the slide.
Take a picture.
Okay, when you finish, tell me.
You can find in LMS in the slides.
Yes, it's not yet on the LMS, but you can find it later. It's actually all written in the slide.
I open it now.
It's already there?
Yes.
Okay. It's actually here. I wrote it here for you. That's my solution, but it's actually written in details in the original slide. Not here. It's all there. This is the first f of minus 2 minus 1, and this is f of a minus 2, which is a squared minus 1, okay? And the lecture here is recorded. I will save the records and send it to you later. Okay. Now another example here. It's the same thing, but different with the place of substitution. Here I have a function. The name of the function is capital R. I can also use a capital letters to name the function. R of x. R of x is defined by this rational function, دالة كسرية, 100x on the top and b plus x in the bottom. Okay? What I supposed to find, they asked me, suppose that b, he gave me a value of b with a 20 like that, and asked me to find r, the value of the function r when x equal to 60. So I have to substitute two things. I have to substitute b by 20 and x here and here by 60 to find the value of r and the dependent variable. Of course, when I substitute inside a function, I find the dependent variable. إذا عوضت في دالة أحصل على المتغير التابع. هنا المطلوب مني أني أعوض بقيمتين اللي هي قيمة البي معطاة ب20 وقيمة الإكس معطاة ب60. Okay? Of course, the second thing is determine the value of b if r of 50 equals to 60. هنا نفس الشيء راح أوجد قيمة البي، لكن راح أعوض بقيمة الار. هذا الطرف كله راح أشيله وأكتب بداله 60 وأعوض داخل الار بدل الإكس ب50. هذا راح نشوفها بعدين. راح نبدأ أولا ب A. Here A, I have to find if b equals to 20 and x equal to 60. So r of 60 like that equals to 100 multiplied by x here. I supposed to substitute it by its value, which is 60. Okay? And at the bottom or the denominator, b, I supposed to write 20 plus the value of x, which is 60, right?
60.
Right, here 60. Okay, here 60 multiplied by 100, 6,000, right?
80.
Yes, and this at the bottom will be 80. Of course, here we have zeros. I can here divide by it, which is here 600 divided by 8. This 6 can be actually simplified by 8. Who can simplify it?
5.
Here I can write 300 divided by 4. This is the final result. Okay, this is the value of r. Okay, this is find r. So I find r of 60, which is 300 over 4. You can divide it by
75.
how much?
75.
Yes, 75. You can actually leave it like that, but when you have maybe multiple choices, you might have it simplified until 75. Okay. Question B. Question B here, I have to find B. Note here that it's different here. I have to find B. So I have R and I have X. So I have to find B. المطلوب إني أوجد قيمة الB هي المجهولة. عندي قيمة الR. عندي قيمة الR وعندي قيمة الX اللي في البسط والمقام. المطلوب مني إني أوجد هذه الB. Okay? So I have here R
50
equal to R of 50 equal to 60, R equal to 60, and X equals to 50, like that. So I can here find B. Of course, here 60, let's change the color, 60 equals to 100 multiplied by X, which is 50, divided by B plus the value of X, yes, which is 50. Here I have a rational number or rational function with equality with a number. So I can divide like that or multiply like that. The numerator together and denominator together. Here I suppose that it's 1. So I can say that here, of course, it's 5,000, right? Equals to 60, yes, multiplied by B plus 50. This is B.
Doctor, it should
be
minus 60.
No, not minus 60.
We move to another side.
No. If you replace the side, left-hand side or right-hand side, you change the sign. But we just here multiply. You don't change the sign in this step. You just multiply here. Okay? Okay, so here to complete, I distribute 60 inside the brackets like that. So here 5,000 equals to 60B. Yes, 60B. Right. Plus how much? 3,000. 3,000. I have already 2 zeros, right? 5 multiplied by 6 is 30, and already I have 2 zeros. Right or not?
Yeah, right.
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 Now minus 3,000.
Yes. Now I have to find B. I have to find the value of B. So 60B equals to 3,000 minus 5,000, sorry. Right? Which is here minus 2,000. So dividing by 60 to find the value of B alone. And also here dividing by 60. Right? Here to simplify.
Doctor?
Yes?
Why you put the minus for the big number? It's with 3,000.
Sorry, here. Yes, here I changed 3,000 and here, right? Yes, excellent. I should actually write it like that. Here 5 and here 3, right? I move 3,000 to the other side and leave 60B in here. Can you understand that? I leave 60B in this side. I leave 60B in this side and move 3,000 to the other side. But I reverse the arrangement of the sides. Okay?
Doctor, plus 2,000.
Yes, this is a plus. Okay, now to simplify. Of course, this will be
200.
Yes, this is 200 divided by 6, which is how much?
33.
3.3.
Yes, 100 over 3, which is 33.3. 3, of course, it's infinite, right? You can leave it 100 over 3.
Infinite.
Yes, you can leave it 100 over 3 or write it like that as infinite repeating decimal. Okay.
Teacher.
Yes.
هون الار مو لازم يكون 50 والاكس 60 نحن حاطين العكس ولا نفس الشيء؟
لا هنا الار هي 60 واللي داخل الار هي الاكس هي 50. اوكي انا كتبتها لكم هنا في البدايه. ار هي 60 والاكس هي 50. اللي داخل الاقواس هي المتغير المستقل اللي اعوض فيه هي الاكس. صح. الاكس طبعا او المتغير المستقل اللي معطى.
اوكي.
دكتور ليش قسمنا على 60؟
هذه هذا سؤال.
ايوه.
أنا المطلوب مني إني أوجد قيمة البي. أنا البي عندي هنا مضروبة في 60. عشان أتخلص من هذه 60 قسمت الطرفين على 60. طبعا الطرفين هذا هو الطرف بعد ما طرحت 5000. بعد ما طرحت 5000 منها 3000. أوكي. 60 بي تساوي 2000. عشان أحصل على قيمة البي لحالها أقسم على 60 فأحصل على 2000 قسمة 60. أوكي. دائما أقسم على معامل المجهول اللي أبغى أحصل عليه اللي هو 60. Okay? Is it clear?
Yeah.
Okay. This is the final result. That's what we have. 75 in the first one and 33.3. Okay. Okay, for the domain of a function. domain طبعا عشان تفهموا اللي أقوله راح أقول لكم المصطلحات أو الفوكابيولاري. domain معناتها المجال، مجال الدالة أو الفترة اللي ممكن تكون الدالة فيها معرفة، مجال تعريف الدالة. domain of a function. Of course, we just present or introduce some types of functions, right? We define, for example, functions f like x squared plus 2, or for example, 1 over x. Another example is the square root. Let's say, for example, x minus 1. Also, we can combine the rational function with the square root function. For example, here, 1 divided by the square root of x. This is some types. هذه بعض أنواع الدوال. عشان أعرف مجال تعريف الدالة لازم أشوف نوع الدالة في البداية. Okay? For example, here, let's begin to understand. Let's begin with the rational function, which is 1 over x. Okay, like that. That one. I will begin with this to understand. Here, for example, f of x is 1 over x. If I give you any value of x, for example, 1, I can here substitute 1 over 1 equals 1, right? If I gave you a negative number, minus 1, it's 1 over minus 1 equal minus 1, right? But if I ask you to find f of 0, it will be 1 over 0. Is that possible? It's not possible. You can't actually divide by 0. This value is undefined value. This is undefined. Undefined. Okay? 1 over 0 is undefined. غير معرفة. Defined like that, yes. Undefined. So the function f of x, which is 1 over x, is not defined at 0. So when we ask you find the domain, it will be defined at all real numbers, positive or negative, but not at 0. I write it like that. It will be the real number r minus, I can write it like that, or a slash like that, minus 0 like that. All the number unless 0. Okay, but not 0. The domain is r minus 0, or I can write it r minus 0 like that. Okay, r minus 0. And also I can write it as an interval from minus infinity. ممكن إني أكتب الدومين كفترة، كاتحاد فترتين منفصلتين. From minus infinity to 0. Okay. United with from minus infinity to 0, from 0 to infinity, like that. Of course, when we present it on the line number, or the number of line, here the 0 will be like that. It will be all the numbers from minus infinity to 0, and all the number from 0 to plus infinity. That will be the domain, but not the 0. Note here that the 0 is an open circle. So here is the unit between, okay, the unit between the two intervals from minus infinity to 0 and from 0 to infinity. Union between. Okay. Samar Omar, you have a question? You raised your hand.
Yeah, is the 0 included?
Which one?
The 0 included or not?
This one?
The 0 is included?
No, it's not included. I write here minus, so it's not included. I just restrict the 0 from the real number. All the real number here is defined for the f of x equal to 1 over x, but not the 0.
So
but
all the numbers, the 0.
All the number but the 0. So here, how can we exclude the 0 from the interval like that? I can write it as a union between two intervals, two open intervals. Of course, these intervals are infinite open interval. Okay? The restriction of a 0 will be like that, r minus 0 or r slash 0, like that. Okay, this is the domain. I can also write domain like that, domain of f. Okay? That for the rational function. So all what I have to do in the rational function, I have to find the zeros of the denominator. لازم أوجد أصفار المقام، أوجد جميع القيم اللي تخلي المقام يساوي الصفر، معناته أن المقام رح يكون غير معرف. أوكي؟ طبعا رح ناخذ أمثلة ثانية ممكن تكون قيم غير الصفر في المقام. أن أساوي المقام بالصفر وأشوف القيم اللي تخلي المقام يساوي الصفر. بس حاليا رح نشوف اللي هي الحالة الثانية اللي هي square root. When will be the square root will not be defined. Okay? So here, I will erase that. For the second type, which is the square root, here f of x equals to square root of x. Of course, from knowing the real numbers, the square root here is defined when the variable x or the number inside the square root is positive, greater than 0, and of course it could be equal 0. Here the square root of 0 is exist. جذر الصفر هو الصفر معرف، وجذر الأعداد الموجبة معرفة، لكن جذر الأعداد السالبة negative numbers is not defined, is undefined. أوكي، معناتها أن دالة الجذر راح تكون معرفة بشرط أن ما بداخل الجذر يكون أكبر من أو يساوي الصفر. هذا شرط تعريف اللي هي دالة الجذر. The square root function is defined when the inside the root, when the function inside the root is positive or zero. Okay, for example here, f of 1 is the square root of 1, which is 1. This is defined. F of 0 is the square root of 0, which is 0, defined. Okay, I also could say square root of 7, which is square root of 7, like that. I can actually take 7 out of the square root, but it's defined. It's actually a real number. So this is defined. But if I take a negative number, for example, here -2, the square root of -2, it's not a real number. I write it like that. It's not a real number, okay? It's actually a complex number or imaginary number. It's not in our domain. I only want the domain on real numbers. So here, the domain of f or the domain is equal all the real number, but the positive one. So I write it like that. Positive number, of course, with 0, like that. Or I can write it like that, from 0 to plus infinity, like that. And when presented on the line number, from 0 to infinity. This will be the domain with the 0 included. In the square root, I can include the 0. Okay? This is the domain of the square root function. Okay? Of course, I write here x, but here for x minus 1, it will be a different one. Okay? When this inside the root is not only x, here x minus 1, it will be different. Here will we say, we'll see now, for example, here, when it's x minus 1, for example, it will be different. Of course, it also different for the rational function. Here, for f of x equals to x minus 1, I take all the function inside the square root, which is x minus 1, that should be greater than or equal to 0. All the things inside the square root. Okay, x minus 1 will be greater than or equal to 0. كل اللي داخل الجذر لازم يكون موجب، اللي هو x minus 1. أخذ كله وأحط لنا يكون أكبر من أو يساوي الصفر. بمعنى أن which means that when I move -1 to the right hand side, x greater than or equal to 1. I change the sign when I change the side. Okay, so here the domain of f will be here x greater than or equal to 1 will be the interval from 1 to infinity, like that. Okay, how can you write the interval? Write the interval you presented on this and the line number x greater than or equal to 1. Since here I have the equality, so I write it a solid circle like that with 1. This is a +1, so here a +1. Okay, and x greater than here the infinity, and here minus infinity. This is fixed. Okay, الأعداد اللي أكبر من الواحد تكون من جهة اليمين. from the right. Okay, so this is x greater than 1. So this is the interval. The interval will be from 1 to infinity, closed. From 1 to infinity. Okay, this is the domain of f. Okay?
Okay.
Okay. Now the last type of function, which is both rational and square root function. Okay. Now, it's actually the same thing, but you have to mix the two possibilities or the two conditions here from the square root and the rational function. Here I have, for example, f of x equal to 1 over square root of x. I have here a rational function. الدالة الكسرية تكون معرفة بشرط أن المقام لا يساوي الصفر. The denominator is not a zero. And also, the square root is defined when what the inside the square root is positive. So the denominator اللي هو المقام اللي هو الx هو الشرط راح يكون كله في جذر الx square root of x. It's supposed to be greater than, sorry, what's supposed to be not equal to 0. Sorry. It's supposed to be not equal to 0. Okay, this is for the rational number للدالة الكسرية. هذه عشان أعرف الدالة الكسرية. And also, what inside the square root, which is x, is supposed to be greater than or equal to 0. But I will not put the equality here, since I can't here have a 0 in the denominator. مش المفروض إنه يكون عندي صفر في المقام. فهنا الشرط اللي أحتاجه, the condition that I need is x greater than 0. Okay, so when we have a square root in the denominator, لما يكون عندي جذر لكن في المقام راح يكون نفس الشرط للدالة الجذرية, the same condition for the square root, but without the equality with 0. الشيء الوحيد اللي راح يتغير عن الدالة الجذرية اللي دالة السكوير روت إني ما راح أحط مساواة مع الصفر. هذا بس اللي راح يتغير. يعني الدالة الكسرية هي نفسها الدالة الجذرية لكن راح يكون من غير مساواة مع الصفر. Okay, so this is the domain. Domain of f will be all the real numbers from 0 to infinity. It's the same but without equality with the 0, with open circle here at the 0 until infinity. Okay, all the number greater than 0 and here minus infinity. That's the domain of f. Okay, Abdullah Aqil, you have a question?
How did you write the domain of the second example? I didn't understand it.
This one or the previous one?
The second example. No, second example.
This one?
The one before.
This?
Yeah.
Okay. This one is 1 over x. This is a rational function. The rational function is defined with the condition that the denominator, اللي هو المقام, is not equal to 0. When I write 1 over 0, this is undefined. This is undefined. I can accept any value like that, dividing by 0. So the domain of f will be all the number except the 0. You mean maybe how can I write the union between the two intervals, right? I just draw the line of the numbers, then the number which is here 0 that I want to exclude it, الرقم اللي أبغى أستبعده من الفترة, and draw as an open circle like that, and take all the number in the right and all the number in the left. This is two different interval. Okay, this is from minus infinity to 0, and this is from 0 to infinity. So I write it like that, from minus infinity to 0, open, union with from 0 to infinity like that. Okay, this is the domain of f for the rational function. I write it as a union between two interval. When I exclude, لما استبعد one number, it divided into two intervals from minus infinity to the number and from the number to infinity. And my number here is, in this case, is a 0. Okay?
Okay, thank you.
Okay. Of course, we will have more examples. You will understand it more later. Okay, the example that we didn't discuss here is this example, x squared plus 2. This I called it polynomial. Polynomial اللي هي كثيرة حدود. كثيرة الحدود اللي تكون لا تحتوي, it doesn't contain any rationals or any square roots or any trigonometric exponential, nothing else. Only exponents or powers on x, like that. Okay? The domain of this function, not here x, and a constant which is here 6. So I can here actually replace x with any number. I will not have any undefined value. There is no division with a 0. There is no square root of a negative or anything else. So it will be defined for any value of x. So the domain here is R. Actually, so many function that I have here, the domain is R. Okay, the domain of this function will be R. The definition here of a domain of function is written like the set of acceptable value for the variable x. جميع القيم المقبولة أو الممكن التعويض بها في المتغير x. أوكي؟ هنا أقدر إني أعوض بأي قيمة للمتغير x، ما راح يكون عندي أي قيمة لعدم التعريف. عشان كذا أقدر أقول إن الدومين بهذا الشكل، الدومين للf يساوي الr. domain equals to r. أقدر أكتبه كinterval. I can write it as an interval from minus infinity to infinity, or x between minus infinity and infinity, like that. Okay?
It's always be a.
كيف؟ Who asked a question?
Me.
Repeat again.
It's always BR.
Yes, R is all the real number. The domain is R. You can write it only like that. Domain is R. Of course, this is another type of writing R. You can write R, or you can write x between infinity minus infinity, of course, without equality. There is no equality with infinity. Or you can write it as an interval. This is all the line number.
Okay.
The line of numbers. Okay, this is the square root. As we said, you take the value inside the square root, which is here x plus 2, and take it greater than or equal to 0. Okay, then write x, or find x alone in the left hand side. So x greater than minus 2 or equal. So this will be the interval from minus 2 to infinity. The 2 is included since I have here the equality. I write here equal to 0 since it's a square root. Okay, it's not rational. هي ما هي في المقام، هي فقط دالة جذر تربيعي. أقدر أعملها مساواة مع الصفر. الصفر داخل ضمن الدومين. Okay. And this is the rational function, the domain of the rational function here. طبعا ما عليه من البسط. Ignore the numerator. عليه بس من القيم اللي تخلي المقام يساوي الصفر. أمسك الدينومينيتور اللي هو المقام. x square minus 4 doesn't equal to 0. Not equal to 0 when it doesn't equal to plus or minus 2. How I can get this? X square minus 4. It's not equal to 0. So x square, it doesn't supposed to equal to 4. I take the square root of the two sides. So x equal to plus or minus 2. Always the square root give me plus or minus. Okay? Since plus 2 square is 4 and also minus 2 square is 4. So the square root it could be plus or minus. And I can write it like that. The domain is R minus, not here, this is a slash, or you can write actually a regular minus, okay? Minus plus or minus 2. Plus 2 and minus 2. You can write it like that or like that. Okay? And this is a rational function with a square root in the denominator. I take only what's inside the root in the denominator and take it greater than 0 without equality. I omit here the equality since it's in the denominator. I can't have a 0 in the bottom here. Note here that I have 3 minus x. So I move x to the other side. So I have like that, 3 greater than x like that. Here x is in this side. I write it or I read it x less than 3. Okay, so here x is less than 3. I always pay attention to the sign of x. Okay, when I move it here to other side, it will be positive. So, but this sign will not be changed. It will be plus x in this side and plus 3 in this side. But I write it from here, x less than 3. And you can write it like that, x less than 3. And I write it as an interval like that, from minus infinity to 3. Okay, and the line number, it will be here 3. X less than 3 from the left, so it will be here from minus infinity to 3. Of course, here it will be open, and here is positive plus infinity. This is the domain. Okay. Okay, the final thing that we will have today is the graphs of functions. For example, if I have a function f defined by, let's say, 2x. Let's take just a simple function like 2x. When I ask you to make a graph or sketch a function, draw a function, sketch a function. طبعا هنا نتكلم عن رسم الدالة، الرسم البياني للدالة. لما أطلب منك إنك ترسم الدالة، كيف راح ترسمها؟ I just take a table like that. Just a moment. Like that. And here, I suppose some value of x and substituted in the function f to find the value of y, which is here y. Here the value of y. هنا راح أفرض قيم للمتغير x وأعوض في الدالة f عشان أحصل قيمة المتغير y، عشان أحصل على نقاط أمثلها بالرسم. Of course, I can take here, for example, 0, minus 1, minus 2, and also I can take 1, 2, and so on. راح أكتفي هنا بهذه القيم. To find y, أعوض هنا I substitute here 2x. To find y here, 2x, 2 multiplied by minus 2 here is minus 4. Yes. And here, minus 1, when I substitute it here, yes, minus 2. And here, 0. Here, 2.
4.
And 4. Okay, I will take these 5 points and present it or sketch it on a plane. Sorry, here. Just draw a y-axis and x-axis like that. Okay, here will be the y-axis, the value of y in this axis, and the value of x in this axis. راح أمثل قيم الx على هذا المحور axis وأمثل قيم الy على هذا المحور in this axis, y-axis, x-axis. Okay? Okay. Here, I have here 0.
And 0.
And 0. So the value here will be 0 and 0. This is a point. The second one at 1. This is the 1. And the value of y with?
2.
Which is 2. So here 1. And here 1, 2. This is 2. So this will be the point. Okay? And also, when x equal to 2, y will be equal to 4, right? So this will be the point, like that. And for the negative value, I have here minus 1 and minus 2. Minus 1, it will be, y will be minus 2. This will be the point. And for minus 2, it will be minus 4, right? This is the value of y. This is the value of x. It will be at here, okay? You don't draw a line between the 2 points, no. This is the value of x, and this is the value of y, so you draw a point like that. Now, since I have here, actually 2 points in this case will be enough, but when you have, for example, here square or more, you will need maybe 5 points to find the value. Okay, here, I just draw a graph that connect all these lines. Of course, I note that it's actually a line like that. Okay. It's supposed to be here. Okay. هو عبارة عن خط مستقيم يوصل لجميع النقاط. هذا الخط المستقيم هو عبارة عن f of x equal to 2x أو ممكن أكتبها y equal to 2x. This is the graph of this function. How can I make a graph or sketch a function? By making this kind of table, then dedicate the point and sketch a line or a graph that connect all these points. Okay? Abdullah Khalid, you have a question?
Yes, doctor. I can use any numbers like you did,
Yes.
-2, any numbers that I like.
Yes, you can find any number instead of x, but it should be in the domain. For example, when I ask you to draw 1 over x, you can actually use 0. Okay, you can use the 0.
Okay.
You can here actually substitute with any number when it's in the domain. Okay, you also can use a rational number. ممكن انك تستخدم كسور، ممكن تستخدم اعداد موجبه سالبه صفر، بشرط انهم يكونوا جميعا داخل الدومين. Then sketch a graph that connect these points.
وش اللي يحدد الاعداد هذه؟
كيف؟
اللي يحدد الاعداد هذه الفليكس.
اللي يحدد this numbers، انت هذه الاعداد ممكن انت تجيبها من عندك، ممكن انت تختار اي اعداد للاكس، لكن الاعداد اللي هنا اللي هي الواي تجيبها من التعويض بالقيم اللي انت اخترتها اكس هنا. اوكي، هذه اعداد اختياريه اخترتها أعوض فيها هنا عشان أوجد هذه الأعداد، فتكون كل قيمة هنا تقابلها قيمة هنا، هذه تمثل نقطة. أوكي؟ This is a point. أمثل النقطة، وبعد ما أخلص جميع النقاط اللي افترضتها I make a graph. I draw a graph or sketch a graph. Okay, this is an example. I gave it to you. There is another example in the slide, which is here x square, like note here, x square. Here he take 0. 0 square is a 0. 1 square is 1. 2 square.
8.
Square or cubed? This is a cubed, sorry, not square. 2 to the power 3 is 8. 3 to the power 3, 3 cubed is 27, and so on. Of course, when you take a cubed with the positive, can you mute your mic, please? When you take the cube, for example, here -1 cubed to the power 3, it will keep the sign. It reserves the sign here. -2 to the power 3 is -8. The sign is it's not changed when you take an odd exponent or odd power. Okay. Then here he placed the points here, 0 and 0 in here. 1, 1 is somewhere here. Okay. 2 and 8. This is 2 and 8. This is 2, 8. This is 1, 1. And this is a 327. This is a 3 and 27. Okay. And also the negative values here. Then he sketched a line that connect all these points. It's not a line, it's a graph. Sketch a graph that connect all these points. Okay. Okay, this is the definition of the graph. A graph of a function is the set of all point x and f of x. F of x, which means y, the dependent variable, x and y. جميع النقاط اللي تكون فيها x, y اللي تمثلها الدالة f of x. Okay, where x is the domain of f. As we said, I can choose any value of x, but it should be in the domain. All the domain of f of x. طبعا هنا الدومين للدالة x تكعيب هي all the real numbers are. Generally, this forms a curve. هنا curve بمعنى منحنى. هذه النقاط للدالة x cubed is a curve like that in the xy plane. xy plane اللي هو المستوى xy. لما أرسم محور x ومحور y هذا أسميه plane أو مستوى. Okay. I think that should be enough for this lecture. Okay, I will just take the attendance now. I will download it from here, but I will call your names. Okay. Okay, I will. Okay. What is your name? Just hold on for a second. I put your name somewhere here. Just hold on for a second. تسجيل المحاضرة أنا عملت لها ريكورد، بس خليني أوقف الريكوردينج. أيوة راح يكون في إن شاء الله تسجيل، بس خليني أحفظ الريكوردينج، وأول ما أرفع على LMS هو ممكن ما يكون على LMS، إذا ما قدرت أحطه على LMS ممكن أرسله لكم بالإيميل. أوكي just
اوكي.
أوكي بس خليني أشوف بس الاتندنس في البداية. أوكي انتو 129. اوكي